afterward. I have made it more strict and almost kicked somebody out yesterday because I went to the restroom and came back and they were distracting people. So yeah, math lunch is not like, if you've been there and people have been talking or making jokes or whatever, we're in heavy catch-up mode. So we're not goofing around at math lunch or anything like that. We're doing math. So the first thing I need to do is get a lunch count. Speaking of lunch, so our options today are chicken drumstick, mac and cheese, hamburger, cheeseburger, cheese pizza, pepperoni pizza. So I need to know how many people want chicken drumstick / mac and cheese. 1, 2, 3, 4, 5, 6, 7, 8, 8. 1, 2, 3, 4, 5, 6, 7, 8. John, your hand is not up, right? Okay. 8 there. Hamburger. Who wants a hamburger? No cheese on it, just hamburger. Big old goose egg. Cheeseburger. Throw some queso on that cow. No? Cheese pizza? Ooh, Antonella, we're going to need to make sure that I got your lunch count if you want. So, Eve and Carmen, cheese pizza. Anybody else? Cheese pizza. 2. Pepperoni pizza. 1, 2, 3, 4, 5. So, nobody else in here is eating, or did I miss anybody? Do you need to add yourself to any of these counts? Pepperoni pizza. Anybody else? We only got like 16 of you, so I'm guessing a couple of you are Packers, or maybe don't eat. Guys, make sure that when we're doing this, it would be better for you to raise your hand and add to a count, and then not eat it, as opposed to if you might decide, oh, I do want lunch, they might not have food for you. So you need to raise your hand if you're thinking that you might want lunch. What do you want, Kate? I mean, that's life. So you gotta pick something and then, I guess, eat the sides that come with it and whatever. So what do you want me to mark you down for? I mean, I've heard the mac and cheese is pretty good. Do you like mac and cheese? All right, well, what do you want me to put you down for? All right. Cool. Get out and let's chat with your teams real quick about what you want to bet on. If we're going to bet evens or odds, and how could we determine which number to choose? So the one spinner has 2, 3, 4. The other one has 6, 7, 8. Right, so our 2 spinners. Oh, we need to check homework. Sorry, I'm going too fast. Lunch count has me all goofed up. My bad. Let's check homework. My bad. Let's check homework. Sorry, 526. 526. Let the questions fly. Who wants to see any of this? Mia? I can find my 526. Guys, 84, I will be checking. You have the formulas there on your paper. So please actually do 84. Like, break up the shapes. Do the area for both of the shapes. If you just write down these answers, I will give you a check minus. Like, promise, pinky swear, Scout's honor, whatever you want to say. We gotta know how to find area now. So if you are just writing down answers, you will be getting a check minus. You will be coming to work with me. So please don't just do that. In 85, that's what you said, yes? Yeah. In 85, it says Rachel's collecting donations for the local animal shelter. Aw, thanks, Rachel. So far, she has collected $245, which is 70% of what she hopes to collect. We have a few different ways that we can get around this problem. We can do one of those percent number lines. There's a lot of ways. But guys, my favorite way is that Meineke method. If 245 is 70%, I could work from there to get back to 10%. How can I get from 70% back to 10%? Divide by 7 on top and bottom. Thank you, Vincent. So, 245 divided by 7. Grab that calculator just in case we make any mental mistakes. 35. So, if $35, because that's what we have on top, is 10%, how do I get to 100%? Times 10. So, she, in total, wants to collect $350. There are other ways to do that. But I think breaking it down to 10% and working from there is one of the ways that makes the most sense. Not E-word, but it makes the most sense, right? If we can break it down and then build it up, that works really nicely. And you've got a calculator. How many times this year have I said don't use a calculator? I can count them on one hand probably. It's probably been like 3 times that I've said no calculators. Other questions? Mia? Mia's just trying to steal Eve's spot of being the best question asker. Now it's like a competition. Darnell is designing a new game. He will have 110 different colored blocks in the bag. I would highlight that because that feels important. 110 different colored blocks. So that seems like it's probably going to be our total. While a person is blindfolded, he or she will reach in and pull out a block. The color of the block determines the prize according to Darnell's sign over here. I would like purple. I would dig a new hat. So, if he wants players to have a 60% probability of winning a small toy, how many blue blocks, because blue relates to small toy, might as well grab my blue pen. Guys, I do enjoy those of you that highlight and color code and like make your homework look nice. I pay attention to that, and I do appreciate that. So, 60% of all of our blocks should be blue. So he wants blue to be 60%, which we know is 0.60, because 60% is 60 hundredths, times how many total blocks do we have? 110. So again, grab that calculator. 66. We would solve B the same way, but I'm not going to do it for you. We would write out that green is going to be 10% of the 110 blocks and solve it there. I think you can probably do 10% a bit easier than we did 60%. John. 89 on that next page. Anything else from this page, I guess, before we move on? Lucas, how was your yogurt and your apple? Was it delicious?
I was like,
Lucas is like, why does Mr. Hudson know what I ate? I love yogurt. And man, my wife found like the biggest apples in the grocery store this week. I think this is like the size of my face. 89. A bag contains 3 red, 5 yellow, 7 purple. Guys, the first thing I always do when a situation like this comes up is I think about the total first. 3, 5, and 7 total up to be 15. So I kind of make a note or a mental note of that. Find the probability of drawing a purple marble followed by a red marble. The first marble is put back in the bag between draws. So there are different ways that we could do this, and I'm really happy that you asked about this question because this is new. This is what we just started looking at yesterday, and I actually don't know if we had enough class time to really talk about this. When we did the problem with the fish, the tetras and the guppies, and the different colors of them, when we did this problem, what I don't know if we had a chance to talk about is one of your classmates came up, and this is written because the afternoon class, sorry, sometimes you guys get the better lesson and sometimes they get the better lesson. I can't be identical twice, right? It's a little tough. So our chance of getting a tetra is 1 out of 2, right? So that cuts our table in half. We can actually do the math if we just take the fraction 1/2 times our chance of getting silver is 1 out of 4. So if we multiply these fractions together, it will tell us the chance of that single event occurring. So what we need to do for this homework paper, and at this point you are allowed to like write what I'm writing here because we're doing it together. Our chance of getting a purple marble is what? And I'm writing in color, so you don't really have to label it, but you could, that this is our purple. And then followed by a red. Where are my red pens? What's the chance of getting a red? 3 out of 15. And we multiply across the top, across the bottom. I think I know the top one on my own. Yeah, 21 would be on top. Over 15 times 15, I think that's 225. Yeah, it's 225. Be careful. 15 times 15 is 225. So that is the compound probability. And actually, guys, who would like another day to get this homework done? Like, who's not done with this yet? Let's make it due tomorrow. So, like, please don't try to get it done super fast if it doesn't make sense. Let's move this to being due tomorrow. You do not need to turn it in today. I would love for you to come to math lunch or AO if this stuff still doesn't make sense. If it is done, sure, after we get done checking it. Mia? 90. So this is just, I forgot to change what it had typed. When I give you the graph right here, you don't have to use separate graph paper. I did this to make your life easier and make my life easier, because when I go to check your homework, I can see it right here. It also makes it easier to know if you skipped problems. So the problem with this graph is I don't have any axes set up yet, right? We need our y-axis and our x-axis somewhere. To determine where we're going to put our axes, we look at our points first. So for the x values, 2, -2, -2, +2, I know I could put my y-axis pretty much in the middle because I need positive and negative x's. For our y values, +3, +3, -3, -3, I also need positive and negative values, so I can put my axes, both of them, pretty much in the middle of the paper, in the middle of the graph space. Here's what I'm going to be checking, guys. XY of +2, +3 goes right 2 and then up 3. Make sure you're doing X, then Y. The X-axis is your horizontal. The Y-axis is your vertical. So -2, -3 is left 2 down 3. Sorry, that was that next point. -2, +3. Up here, +2, -3. So what do we end up with? A rectangle. And I am not going to do the area and perimeter for you because I think we can figure that out once we get these points graphed. Then this is seeing if you can think through this. Once you figure out the original area, to make the area 32, should I bump like a couple of the points to the right? Should I bump a couple of them up or down? Like, how much do I want to increase the area by? Just remember that each one of these blocks is an area of 1. So if I bump it to the right, I could add 6 to my area. If I bump it up or down, I could add 4 to my area by just moving a couple points. And if you want to color code, like if you move the points and you grab another pen and you say like, oh, these are the new ones. Yeah, that's totally fine. I mean, you killed another tree, but no, I'm joking. It's fine. We use a lot of paper in this class. I get it. There's no avoiding it. Back to the answer key real quick to see how people are feeling. So I said I'm not doing it for you, but I am showing the answers to you. I would obviously like to see some work written out. So the rectangle area originally is 24. We want to bump it up to 32. So you can figure out how to do that.
For 591, are we supposed to do like
Dollars divided by pounds. So whenever we're looking for a unit price, Guys, and I give you the hints right here. I typed this stuff in. Price per pound. This is telling you what to do. Because per tells us to do what? Divide. So it's dollars divided by, guys, hashtag originally meant pounds. This symbol means pounds. Then TikTok stole it. Or Twitter or whatever used it first. But this meant pounds before it meant anything else. So dollars divided by pounds will get you the 85 cents per pound, which is cheap. I don't know if pears are in season then or not, but I mean, that's pretty darn cheap. Layla? 92B. So I will do B and then maybe one more if people ask for it. But guys, this is order of operations. You have to show work. There is zero chance that you can solve this without showing work or trying to use a calculator for the whole thing, which you should not. Because your calculator could mess it up. No joke. Your calculator screws up math if you try to tell it to do too much. Because it can't think like we can about the order of operations. It just follows what it's been told to do, which sometimes makes a mistake if I don't type this in particularly. So order of operations, I always suggest, and anyone who I've helped with this, I draw the order of operations ladder like that. We start with parentheses, everything else we drop down and don't do anything with. 8 times 3, 24. This is what I meant by work vertically. A couple of you came and asked me, like, what do you mean work vertically? I mean just go down, right? Don't try to go left to right, go down. So then exponents. So 6 squared is 6 times itself. Double check this. This is a common trap door. Double check that you did not write 12. 6 squared is 6 times 6. That's 36. I don't really need these parentheses anymore that were around the 8 times 3, so I can get rid of them there. 2 squared, 4. I do still need this parentheses because it's indicating that I multiply here. 4 times 21, 84. And then if you're out of space, now you can bump your answer to the right if you want. Remember, guys, we work left to right. So you would do 36 minus the 24, and then add the 84.
It comes up to be
96. And then, guys, if you would circle your answer or put it in a box or something so I can, like, so it's easier for me to tell that you finished, right? Because sometimes we get cut off in the middle of our homework and we don't get finished. So when you get to your final answer on a problem that has a lot of steps, circle it. Put a box around it. Draw a picture around it. I don't know. Some of you guys like then draw like a heart or a flower or something. A lot of you, all of you are better artists than me. All I can do is draw math. We got to dive into the lesson because I especially want us to do the mystery spinner. So if you need more help, please come to math lunch. All right, so if that's totally done, you can turn it in. Otherwise, turn it in tomorrow. I've just made my peace with being a little behind right now, and we will cover whatever we cover. If we don't get through the whole book, guess what? I just told Mr. Hall that we didn't get through the whole book, and he knows. That's why it's sweet that next year your math class is that far away. And Mr. Hall is like an MVP math teacher. He is awesome. All right, ready to roll? We had these mystery spinners yesterday, and we told you that on the spinners were, I don't remember because I got to scroll to it, 2, 3, 4, 6, 7, 8. If you did not make a table yet, make a table to try to predict the outcomes here because we're going to add the numbers together. So with 2 events, right, like 2 spinners, we are allowed to make a table. So if we make a table for this, 2, 3, and 4 would be on one side. 6, 7, 8 would be on the other. It would probably look something like this. 2, 3, 4, 6, 7, 8. If it was my table, I'd probably put the 2, 3, 4 on the top. So here, I'll draw another one to show if you drew it going the other way. So if you're like me, the thing you say first, you probably are thinking about put across the top. Now, you could write down the number, or you could just write evens or odds. So 8, 9, 10, 9, 10, 11, 10, 11, 12. And if I code it, even, 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 even. How many evens are there? 5. How many odds are there? Okay. Decide with your group if you're picking evens or odds. Eli, what's your group picking? Even. Antonello, what's your group picking? Even. Farah? Kylie? Murray, not here. Carmen? Ooh. Y'all agree. I've never had a class that agrees so much. Franco, what do you guys want to pick? All right, everyone is picking even, I guess. That means I get odd, I guess. Miss Martin, are you going to be on my team or their team?
I'll be on your team.
Yeah, teachers versus kids. All right, you guys got to write down our results, okay? How many times do we want to say we're going to do this? 10? 10? 10's a nice number. We got a 3 and an 8. Ha-ha, I'm starting off in the lead. That's an 11. We got a point for odd. So if you guys want to make like even, odd, and like kind of make check marks or tally marks or something. All right, second spins. 3 and 7. You guys got one. Third spin. 3 and 6. Man, 3 seems popular out the gate. We've only had 3s over here. So we're up on you guys by 1, right? It's 2-1. Spin, spin, 3 and 6 again. Heyo. Spin, spin, 3 and 8. Man, 3 seems popular. Anyone starting to get a little sus? I did not, because I didn't make this website. I'm not smart enough. Spin, spin, 3 and 7. So there you go. You guys got one. I think it's 3 versus 2 now. 4 versus 2? Ooh, thank you for being honest. Spin, spin, 3 and 6. A 9. Spin, spin, 2 and 6. Oh, there you guys go. You can come back. You can come back. Spin, spin, 3 and 6. 9. It's pretty much game over, right? Spin, spin, 4 and 8. Ooh, and we got a 4. How many spins is that? Oh, that's 11 now? Oh, that's 10. Either way, who won? So, does anyone have a hypothesis of what might be... Lucas, thank you for raising your hand. Okay, so it could be the law of large numbers that our expected outcome hasn't happened yet. Maybe. Now that is making an assumption, though. And an assumption is a bad thing. There's a bad word inside of assumption. To assume things is really bad. Eve, is that a hand or are you just playing with your pencil? Both? Okay, what are you thinking? The what? That changes. That's a compound event now, right? Because 2 things are happening. So you're right. It's a bit more difficult because there are 2 spinners. John was shouting something out, but he still didn't raise his hand. Layla? Layla wants to see the inside of the spinner. What do you mean I did not tell you. Did I ever say 2, 3, and 4 are equally probable? You made the assumption. Yeah, that's the right reaction to have. This is my... What about, do you think spinner 2 is fair? Like, did it...
Spinner 2's fair.
Did the results came out pretty evenly?
Yeah. Yeah.
Okay, so spinner 2's fair. So if we go back and remake our table, right? Let's go back and remake our table. How much of the spinner is 3? 3/4. How much is taken up by 2 and 4, like each individually? 1/8, right? So guys, if we go back and try to redraw this table more accurately, come on, there we go. 2 would only get, and actually use your graph paper. Let's be smart about this. Why would we be smart about something? I don't know. Let's take our graph paper, and like we did when we knew things were fair, let's make it so that we know things aren't fair. So let's make a table that is 8 wide. 1, 2. Or you could go 16 wide if you want your table to be bigger, but it should be divisible by 8. And let's just go 8 tall. Let's go 9 tall. And you'll believe me why in a second. Or I guess we could go 6 tall. It might look better if we go 6 tall. Let's go 6. Yeah, but you can always make it smaller. So let's go 8 by 6 on our graph paper. And if you would like to label this with something, this is what we call an area model. So our 2 only gets 1/8 of our table. Our 3, well, 3/4 is how many eighths? 3/4 is how many eighths? 6, right? So 3 gets 1, 2, 3, 4, 5, 6 eighths of the table. And 4 just gets 1/8 as well. Then, what did we say the other numbers are? I keep forgetting. 6, 7, 8. So then, 6 and 7 and 8 should get equal splits of the other direction of the table. Now wait a minute. So if I think in fractions, this is 1/3, this is 1/3, this is 1/3. I didn't leave much space, but 2 was 1/8. So we should probably put that like in parentheses. 3 was 3/4. We can just say 3/4. Guys, I'm hoping that you're writing what I'm writing because this is going to be on our next mastery. And then 4 was 1/8. What is 1/8 times 1/3? Careful, we multiply.
It's 2/24.
1/24. So that means that this box would have a 1/24 chance. Because we're multiplying the fractions together. So here I'm going to write this work out. This box would be the 1/3 from 7 times the 1/8 from 4. And we get 1/24. Or, guys, check it. 2/48. If we look inside of the table we just made, there are 48 little boxes. 2 of them are in that section of my table. Right? So 2 out of 48, or we can reduce it to 1/24. And guys, just based off size, we can look at what's more likely here. What does 3 and 6 make? 3 plus 6 is 9. This would be your 10, and this would be your 11. Guys, just looking at the middle of the table, wouldn't you pick odd over even if we're just looking at the middle of the table? This is why we use area models. Area models use space to represent probability. So guys, somewhere on your paper, please write down area model uses space, area, to show probability. It's kind of like a dartboard. What's easier to get on a dartboard? The piece of the pie that goes to the 20 or the bullseye? The 20, right? Because it's got a whole piece of the pie. What's easier to hit on a dartboard? Red or black or bullseye?
Red.
Like red or black, right? Because if you think about a dartboard, sorry, I'm pulling one up for those of you that maybe haven't played darts. Oh, crap, I forgot about the colors. This is why I pulled it up. I should have said black or white. Here, we'll just scooch it over here and then we'll pull one up. I can't tell if you're decent. Like,
A roulette board is black.
yeah, roulette is black and red. That's what I was thinking. But guys, the bullseye is this tiny red circle. The green one is part of the bullseye, but the real bullseye is the middle of it because there's different point values. So this black space would get you 20 points. This black space would get you 20 points. And I believe this red bar doubles it and this red bar triples it. I believe. Because when you play darts, you're playing to 500. Well, there's lots of darts games.
What's
But,
the middle give you?
25 and 50 or 50 and 100.
I don't know.
Yeah, we'd have to look it up. I forget because I haven't played darts in a very long time. I'll be straight up with you guys. Darts normally happen when you're like out at a place with people and COVID. So I haven't really been out at places with people in a while. So think of the area model like if I was going to try to throw a dart at it and hit these numbers, what's easier to hit? Well, right now the odds, and because we know this would be odd as well, this would be odd as well, we got a lot of odd space on here. All right, does that make sense how I guess you could say I rigged it, but really you assumed...
Out of 10, we got 4 of them, and on that graph it showed that there were 4 even spaces and 8.
Yeah, that's not quite why we got 4. All that this really tells us is we should expect more odds than evens. Now, if we did it 1,000,000 times, like the law of large numbers, then we could probably say a couple more things. But if we only do it like 10 times, sorry, I should have been still showing this. This tells us that we should get a 7 and a 4 1 out of every 24 times that we do this. This can't happen when I only do it 10 times. Like, it can't happen perfectly, right? Because my denominator's 10. So that's why the law of large numbers. We got to do it a lot. Now, does this guarantee that odd will win? No. There are, like, you know, sometimes the not so likely thing wins. Anyone, I don't know if we've had a giant lottery jackpot recently. I don't know if we should go down that tangent because, yeah, we don't have time. All right, grab the 531 paper that is in front of you. It has examples from class on it. And if you don't do your examples from class, I can bring it to people. You don't have it. You will get check minuses now. If you choose to not engage in what we're doing in class while we all do it together, you will get a check minus and you will get to do it. You have it right here. I don't know if John got you one or what. Anybody else need a delivery? You have it. I can see it. You what? If you're not here, I know. I keep track of who's absent and stuff. Yeah. So I know who's not here, but also, even if you're not here, you should watch the class video and do it. Right? Like, because that's why I put so much effort into recording my stuff. I have a fancy pants microphone, so you guys don't miss anything. Right? So, like CX is at home right now. Shout out CX. I guarantee he's going to watch this video, because he and I have been emailing, like, all week about what to do. He actually just had his mom bring in a packet of stuff that he had gotten done to turn in, so he's not so far behind. So what we're now going to practice is taking verbal situations, and guys, as you can tell, we're changing topics here. Okay. Crazy is doing the same thing over and over again and expecting a different result. We are now in 531. Go ahead and squiggly line on your... Well, actually, this is on your handout, so never mind. You don't have to squiggly line anything. But what we're doing now is taking words. This is a fancy way to say words to equations. That's all we're trying to do now, is take a verbal situation. Like when I tell you, if I'm, like, say we're comparing height in class, and I say, I am 5 inches taller than John. Or I could say, John is 5 inches shorter than me. Yeah, you actually might be closer in height to me than that. I just threw out a random number. But we can say things different ways. That's what gets confusing. Look at these two situations with your team and see if you can figure out how to write these as equations. There are two different situations, so look at one, then look at the other. I want to give you a couple minutes to play with it on your own first. You can draw a picture if you want. When it says, oh, it's Myra and Dahlia, by the way. Myra and Dahlia. Ooh, I should use random cards. We haven't done much of that today. Antonella. When it says Myra has 15 marbles, what could I write? 15 equals what? Give me a variable you might choose. Ooh, but for Myra, let's make our life easier. M, right? We can say M equals 15. Myra has 15. It's what she's got. It's what she equals. Lucas, if it says this is 10 less than Dahlia, who's got more? Dahlia's got more. Guys, always ask yourself, before you try to do the math, always ask yourself, who's got more? Right? So how should I set my numbers up? So this is, what is the this is referring to? It's referring to Myra. Right? So, Lucas, do you want to take a stab at how we write this? Because we still have M, because they said this is, and that's your M.
You could write it as D equals M marbles, so M equals M.
But I already wrote M equals. I don't really want to erase it. I already wrote M equals.
I meant M.
Could you do M what?
I was going to say you could do M plus 10 equals D.
Yeah, but I already wrote M equals. This is 10 less than what Dahlia has.
Oh, then
How can we write 10 less than Dahlia? Carmen? Do you know how to write 10 less than something?
D minus M.
Are you Carmen? Are you Katie? Katie, how do we take away 10 from something? Yeah, so we can do, if it's 10 less than Dahlia, it's D minus 10. Now, you guys are also right. We could have said, well, D is M plus 10 because we know Dahlia's got 10 more. We could also write that. Different situation. Different situation. But Myra still has 15 marbles. Okay, good thing Myra hasn't lost her marbles. Dahlia has 10 less than Myra. Ooh, careful. Try this on your own real quick. I'm going to watch the clock and give you at least 30 seconds. Dahlia has 10 less than Myra. Guys, what we want to practice is writing exactly what they tell us. So if it's Dahlia has, we're going to try to write D equals. Mia, you want to take a stab at how we could write 10 less than Myra? Careful, what minus what is what we have to figure out. You're right. Franco? You want to take a stab at it? Nah, you're good on it. Eve? You want to take a stab at how we write this? That's all good. If Dahlia has, this is saying Dahlia has, because this is the tricky part. 10 less than means we got to minus 10 from something. So then we ask ourselves, and you guys can just shout it out, what is the something? M. She's 10 less than Myra. So Dahlia's got whatever Myra has minus 10. John, you should probably knock that off before you go to language arts. Especially because you guys are going out in the commons to work. So guys, over here, Dahlia ends up with 25. Over here, Dahlia ends up with just 5. Those are two very different situations. So please carefully, hey, hold on, give me your eyes. Carefully try 531. I don't want it till next week. So if you need to finish 526, please do that today. We will go over 531. Like, we'll talk about it tomorrow, but mainly on Monday, we'll really hit 531. Like, review those answers, take questions, and then keep going. Thank you. Have a wonderful day. Stay warm. Like, tomorrow morning, it's going to be real cold, like it was this morning. Yeah, it's negative wind chills. What's up? Dahlia, so this is 10 less than Dahlia. So Dahlia has Myra plus 10. Yes, because from this second sentence, we can figure out that Dahlia has more. Because they tell us Myra has less, right? Myra has 10 less than Dahlia. So we can turn that sentence around and say, well, if Myra has 10 less than Dahlia, Dahlia has 10 more than Myra, right? Because we can turn things around as long as we switch the middle to be instead of less than, we say more than. Yeah, because if we read it the other way.
I was confused because it was like,
It is confusing. That's why we got to practice it. That's why we got more practice things from class that we'll do tomorrow. And then you got your practice work. Yeah, and there's not too much of this on the practice work yet. The practice work is still a lot of the stuff you've already seen. Then we'll be practicing the verbal to equations. Yeah, thank you.
Will we be working on, like, angles? Working with angles, because I have this.
Is that a cannon?
Basically, it's a wooden cannon.
So the easiest way for me to show you the answer to that is contents. So we are here. Probability in solving word problems. After this, we are heading into equations and inequalities, which is why we're doing what we just started today, is literally to build equations and inequalities. Then this is a lot of review of what we've already done with proportional work and interest, but interest is down here, but percents just gets one step further that we use it for interest problems, like where money makes more money. Then we get into angle relationships in chapter 8.
Got it. So, a little bit longer.
A little bit longer, probably like March we'll be doing this. Because this will probably be, like, chapter 6 we'll probably try to go kind of quick with. It depends on how good of a setup we get in chapter 5. Right, so we've got 5 more lessons in chapter 5. That's why I've broken up chapter 5 into smaller mastery, like, tests. Thank you, you too, Isabella. Antonella, I'll see you later. So, yeah, I want to play with that, but I don't want to keep you from language arts, so let's talk later. But I think also you might